Oh, here we go. Greetings, ladies and gentlemen. We're talking about last night's quest. We were taking roots of real numbers. On page 285, here's question 35. 35? 35. So check this out. We actually could do a lot of work on this if we wanted, and maybe I shall. So I've got a fraction raised to an even, and it's negative. Taking a negative and raising it to an even is going to make it positive, first of all. And then if I wanted, well, actually, yeah, let's just think about it, that as positive 1/2 all to the fourth. And now the fourth root and the 4 cancel out. The other way I could think about this, I could actually have taken it from that step and written that as the fourth root of 1 to the fourth over 2 to the fourth equals, and then let's see, 1 to the fourth is 1. Well, and 2 to the fourth, I believe, is 16. And then the fourth root of that is actually 1/2. But you could also actually, if you wanted, you could break up this into top and bottom. But we'll talk more about that in future lessons. So, right. So there's a couple ways you could come to that answer. But the main point is, look at the general outline here. I've got a negative raised to an even exponent. That gives me a positive, and then taking the even root of that gives me the principal root or the positive answer there. So interesting stuff. We'll consider that a little bit later today. Here we go. We've got the cubed root of negative 0.125. What? So watch this. I'm going to rewrite this as the cubed root. Does anyone know? Well, actually, maybe this isn't as obvious, but I could actually rewrite this. I like to think about it like this. 125 over 1,000. Actually, you also could have done this problem using scientific notation. That would have been genius. So I could have this as the cubed root of negative 125 over the cubed root of thou. It's okay. It's okay. Thanks. Thanks. The cubed root of negative 125 is going to be negative, and it is actually 5. And the cubed root of 1,000, what times itself 3 times is 1,000? 10. And then that is negative 1/2. Excellent. The other way you could have thought about this is scientific notation. Hey! It's okay. So that's the same as negative 1.25 times 10 to the what power? I believe it would actually be negative 3rd. But that's actually going to make things a little bit more complicated for us. Right, because the negative 3rd, because I'd have to 1, 2, 3, right? So, and it was getting tinier, so that's why it's a negative exponent. I don't know if you guys recall psi naught right there, but anyways. Actually, oh, sorry, that wouldn't be 1 point. Ooh. I guess this is like pseudo-scientific notation now that I think about it. That's what I meant to do. It's negative 125.
Not there yet. We're not great.
Yeah, that's all right. That's all right. Equals, and cube root of 125 is negative 5. And the cube root of 10 to the negative 3rd, well, does anyone have any thoughts on what that might be?
No, it's 1.
Let's actually add some more work to it then. I could also have written this as the cube root of 125. This negative exponent would tell me to move it downstairs, and that would be 10 to the 3rd, right? And then that would have been, oh, this is negative, and this radical comes all the way down. So I would get the negative 5, and the cube root of 10 to the 3rd is 10. And then that's negative 1/2. So a couple ways you could look at that one. The ones with decimals I always found a little bit intriguing, but there you go. And out here, this is the problem we came to talk about. This is awesome.
I got this from
Well, let's talk about how we could do this. The cube root of negative 27, that is just straight up negative 3. All right. Odd roots can have negative outcomes and can be taken of negative radicands. The cube root of a to the 9th. Think about that. I could rewrite a to the 9th as what cubed? A to the 3rd cubed is the same as a to the 9th, right? Yeah. And b to the 12th, I could rethink of as what to the 3rd power? B to the 4th. So in that case, we'd have negative 3. These cubes cancel out. That'll be a cubed. And these cubes cancel out. That'll be b to the 4th. Right? So there we go. I like those ones a lot. Also, I think someone noticed, maybe it was in this class, there's a relationship between going from 9 and 3 to get 3, and 12 and 3 to get 4. Yeah. And it's actually division that's taking place. In fact, if you thought about this, that the power to a power property, that's when we would multiply the exponents, right? So the root of a power property will actually end up dividing, because raising to a power is kind of the opposite, right? It's the inverse operation of taking the root. So kind of some interesting properties that we can think of that will come into effect later. All right, thanks for watching, Internet friends.
Thanks, guys.